Hello everybody. This is Rahul from Edushastra Free University. So here we are to discuss the solutions of flash test set to Quant 2. Before heading, I would like you to introduce with the quantitative section of GMAT. The quantitative section of GMAT consists of two types of problem. First is problem solving, the second is data sufficiency. Problem solving questions. These are simple multiple choice questions. You are given with a question statement and 5 option choices, out of which only one is correct. The second one is data sufficiency. These question types are unique to GMAT. The prompt asks you a question statement and provide you two statements. The question statement doesn't have enough information to solve the question. The two statements provides you with some information related to the question statement. The idea is to see if by using the information provided in statement 1 and statement 2 you can answer the question or not. So these are the 5 answer choice options. The first one is A. Statement 1 alone is sufficient, but statement 2 alone is not sufficient to answer the question. Option choice B says statement 2 alone is sufficient to answer the question, but statement 1 alone is not sufficient. Option choice C says both statements together are sufficient to answer the question, but neither alone is sufficient. Option choice D says each statement alone is sufficient to answer the question. Option choice E says statement 1 and 2 together are not sufficient to answer the question. Now let us have a look to our questions. So first question is x to the power 2 greater than x to the power 3? The two statements are x to the power 3 is greater than 0 and x is not equal to 1. So this is a data sufficiency question. Have a first look to the question. The question asks me to compare two variables. The one is x to the power 2, one is x to the power 3. So basic approach to these questions are when you have one variable with you, take all the same variables, same side. So in this case, I'll take x to the power 3 on left hand side and I would be left with 0 on this side. Going by our approach, we took x to the power 3 on left hand side, then we took x to the power 2 common and inside the brackets we are left with 1 minus x. So x square multiplied by 1 minus x. We need to tell whether this is greater than 0 or not. See, x to the power 2 is always positive. So I just need to check whether 1 minus x is negative, 0 or positive. So when is 1 minus x negative? When x is greater than 1. When it is 0, when x is equal to 1. And when it is positive, when x is less than 1. So I just need to check whether x belongs to blue area, x belongs to 1 or x belongs to red area. So if I am sure that x is greater than 1, I can tell you that x square is greater than x to the power 3 or not. Or I need to be sure of this x is less than 1 or x is equal to 1. So first statement says x to the power 3 is greater than 0. This clearly tells that x is greater than 0. So this gives me this yellow area. So x can take these values, but this yellow area consists of this blue region and this red region. X can be equal to 0 to 1 or greater than 1. So I have some part of this blue area and some part of this red area. So I cannot be sure that x belongs to 0 to 1 or 1 to infinity. Therefore, statement 1 alone is not sufficient to answer the question. Look at the second statement now. It says x is not equal to 1. This gives me entire number line except x is equal to 1. So again, I have blue region and red region in my domain of yellow region. Therefore, I cannot be sure whether x belongs to minus infinity to 1 or 1 to infinity. Therefore, statement 2 also doesn't help me to solve the question. Let us combine the statements now. By statement 1, I get x is greater than 0. By 2, I get x is not equal to 1. So when I combine the statements, x can take the values greater than 0, but x cannot be equal to 1. Therefore again, I got this yellow area which have some blue area and some red area. X can be between 0 to 1 and greater than 1. Therefore, statement 1 and 2 combined are also not sufficient to answer the question because I am not sure whether x is greater than 1 or x is between 0 to 1 when I combine both the statements. And different answers or different values of x yields to different inequality sign in this equation. Therefore, answer to the question is option choice E. Statements 1 and 2 together are not sufficient to answer the question. Now let us see question number 2. Again an inequality question. Is 2x minus 3y less than x to the power 2? Now different variables on different side. So our same approach. Take x square on left hand side and 3y on right hand side. I get 3y is greater than 2x minus x square. We take this 3 in the denominator and I get this expression y is greater than x multiplied by 2 minus x divided by 3. So this question has been changed to this, right? Now see first statement. It says 2x minus 3y is equal to minus 2. Directly put this 2x minus 3y in this equation. I get minus 2 is less than x square, which is clearly true for every value of x because square of any quantity is greater than 0. Therefore, statement 1 is sufficient to answer the question. Now, second statement. It says x is greater than 2 and y is greater than 0. I have this expression clearly. X is greater than 2 and 2 minus x is less than 0 because this quantity is greater than 2. Therefore, x multiplied by 2 minus x upon 3 is always negative and y is greater than 0. So I have this expression here. This is always positive. This is positive. This is negative. So this total is negative. And here y is greater than this negative quantity because y is a positive quantity. Therefore, statement 2 alone is also sufficient. Therefore, answer to the question is option choice D. Each statement alone is sufficient to answer the question. Now coming to question number 3. Does 5 to the power x is equal to 7 to the power y? Again a data sufficiency question. Let us brief the question statement. 5 to the power x is equal to 7 to the power y. We need to tell this is true or not. Now see, clearly if x and y are integers, the equality never holds true. Never holds true. Why? Because 5 to the power x will always end in 5 and 7 to the power y will end with either 7, 9, 3 or 1 by cyclicity of 5 and 7. So if 5 to the power x is equal to 7 to the power y, x and y needs to be fraction. They cannot be positive integers, right? And when 5 to the power x is equal to 7 to the power y and these both quantities are positive, x would be greater than y. And when 5 to the power x is equal to 7 to the power y and both quantities are negative, then y is greater than x. And be careful that 5 to the power x is equal to 7 to the power y would be equal for some specific ordered pairs only. That means for some specific value of x and for some specific value of y only, not for every xy. Therefore, first statement tells me x is greater than y is greater than 0. This doesn't help me to know the values of either x or y. So clearly, this is not sufficient to answer the question. Look at statement 2 now. It says x and y are both even. As soon as I know both are even, they are positive integers. And for positive integers, we have discussed that 5 to the power x cannot be equal to 7 to the power y. Therefore, statement 2 alone is sufficient to answer the question. So answer to the question is option choice B. Statement 2 alone is sufficient, but statement 1 alone is not sufficient. Coming to question number 4, the second last question. It says if x and y are integers and x minus y mod is equal to 12, what is the minimum possible value of xy? This is a problem solving question as I am given with 5 option choices. First thing to notice here in this question, we need to find the smallest possible value of xy. Therefore, x and y should have opposite signs if possible. Now why? See, if x and y have same signs, then xy is always greater than 0. And when x and y have opposite signs, then xy is less than 0. And I need to find the minimum possible value of xy. So negative quantity is always less than xy. So I need to check if x and y can take opposite signs. So in this case, clearly it can take. For example, x is equal to 1 and y is equal to minus 1. They have opposite signs and satisfy mod x minus y is equal to 12. Therefore, x and y in this case will have opposite signs. Now, second thing to notice, it doesn't matter to me whether x is greater or y is greater because at the end I have to find the value of xy. So if mod opens with x minus y or y minus x, it doesn't matters to me because xy is free of if x is greater or y is greater. So values of x and y are 1 comma minus 11, 2 comma minus 10, 3 comma minus 9, 4 comma minus 8, 5 comma minus 6 and 6 comma minus 6 if x and y have to have opposite signs. So clearly this yields to maximum value, that is mod of maximum value, but the value is actually minus 36 and this is the minimum value. This yields to minus 35 and other clearly are less than these. So I have for 6 comma minus 6 the minimum value, that is minus 36. So minus 36. So the right answer to the question was minus 36. Now let us move to the final question, that is question number 5. What is the absolute difference between the cubes of two different non-negative integers? This is again a data sufficiency question as I am given with two option statements. So let us assume two numbers to be a and b. I need to find the value of a cube minus b cube. The first statement says one of the integer is 2 greater than the other integer. So let us assume the integers a and a plus 2. Now put in the equation, I need to find a cube minus b cube, right? So a plus 2 cube minus a cube. When I open the brackets, a cube get cancelled and I am left with 3 a square b plus 3 into b square a plus 8. Right? Therefore, statement 1 alone is not sufficient to answer the question because I do not know the value of a. Hence, I do not know the value of this expression. Now, look at the second statement. It says the square of the sum of the integers is 49 greater than twice the product of the integers. That means a plus b ka whole square is equal to 49 plus 2ab. When I open this whole square, I get a square plus b square plus 2ab is equal to 49 plus 2ab. This 2ab gets cancelled and I get a square plus b square is equal to 49. Clearly, we have only two ordered pairs for this, that is a is equal to 0 and b is equal to 7. Since we were given we have two non-negative integers. And the other ordered pair is b is equal to 0 and a is equal to 7. So I can find the difference between the values of the cubes. Therefore, statement 2 alone is sufficient to answer the question. So right answer to this question is option choice B. Statement 2 alone is sufficient, but statement 1 alone is not sufficient. That's all for this flash test. Thank you and have a nice day.